Continuing in part 2 of exponents, another rule to add to your list here, the power rule for exponents. Now remember, the other one was the product rule, and I'll write that one out for you just as a little review here. That was a to the m times a to the n, and we got a to the m plus n. Now in the power rule, we have a base with an exponent inside a parenthesis that's raised to an exponent. So here the rule is a to the m n. That is, you're going to multiply. So you really have to watch this because students sometimes get confused. This up here is the product rule. And this here is the power rule. Now they both start with a P. Product, we're going to multiply variables. Here we just add the exponents. But here we're taking an exponent in a parenthesis and raising that to a power. An example would be like a to the third raised to the third. Now remember what that is a to the third times a to the third times a to the third. So this is going to be a to the ninth. And here the shortcut rule of addition is multiplication, and that gives us a to the ninth as well. So you could take this and write it this many times if you get stuck and you're not sure. All right, well, let's go on because there are going to be some challenging items coming up here. This one's easy. The power rule, this is just going to be a to the eighth. Now here, the rule for multiplication signs work. So this would be 5 times negative 2 is x to the negative 10 in the numerator, but we have to bring that down to our denominator to make it positive. So it becomes 1 over x to the 10th. This is another way to do it, but I would suggest you do it this way, the first way. Comes out the same. So this one you can almost do mentally. This is going to be y to the negative 14. That becomes 1 over y to the 14th. Now here we have 2 to the negative 6. So we're going to bring that down to our denominator as 1 over 2 to the 6th. And 2 to the 6th is 64. So sometimes they'll ask you to simplify things. And in cases like this, that's usually what they want. 1 over 64. Now, they're also saying another way to do this is you could have raised 2 to the third power, get the 8, and that would be 8 to the negative 2, which is 1 over 8 squared, and 8 squared is 64. It comes out the same. So as I mentioned earlier, there are slightly different ways to do things. Now, if you see two variables within a parenthesis and it's raised to a power, there's a 1 by the a, 1 by the b, so you would get this. So keep in mind, and let me just go over this one a little bit here. There's a 1 by the 5. So this is going to be 5 to the second, and then x to the second. And 5 to the second is 25, x squared. Perfect. Now here, remember there's a 1 by each of these. X to the third, y to the third. Now here we're raising a negative 7 to the second power. So that's going to be, when we have a negative value raised to an even power, it's going to be positive. And we can see negative 7 times negative 7 is a positive 49. A to the second, b to the second. And here they're laying it out for you. And there's the answer. Now, a shortcut way might just put this 1 over this to the 5th in the denominator. Or you could multiply each of them through and then bring each of these down to your denominator as this, which becomes this. So there are some shortcuts you can make once you understand what's going on. And here they're just illustrating that if you have something to the negative power, again there's a 1 in there, you can bring that whole things down and then multiply through. There's a 1 there, and you get this. Now notice some will stay up, some will go down. So this is going to be x to the 8th in the numerator, y to the negative 12 in the numerator, but you're going to bring it down to the denominator to make it 12, a positive 12, as they show here. So again, the proof of your pudding would be that, working on your practice and then later your certification, that you get these correct. And hopefully you know through taking good notes and seeing how things work and then studying it, get to develop mastery of this. Now, here's where it gets a little tricky. And let me give you a little background on this one here as well. We had said if you had a negative 7 that's raised to the second power, that because the base is negative 7, this is negative 7 times negative 7, which is going to be a positive 49. But suppose you have, without the parentheses, a negative 7 that's squared. Now, what's the base here? Is the base negative 7 as it is here when we have parentheses? And the answer is no, the base is only this. So the protocol for this is you square the 7, get your 49, then you bring over your negative sign, so this ends up being a negative 49. And they're illustrating it this way, which is very nice, I think. Okay, so keep that in mind. If the base includes the negative sign, you would get this. Even number of powers, a negative is positive. But if the base is only the 7, then you later apply the negative sign. And that's what they're illustrating here. Okay. Now, looking at this a little further, too, this is what they illustrate. Now, how about if it's to the 0 power? Again, what's the base here? Is it a negative 2? No, it's only the 2. So 2 to the 0 is 1. Then we apply that negative sign to it. Now, notice the difference. Here the base is negative 2. Here the base is only the 2. So you could think of it as a negative 1 out there as well. I like that. All right, now the rule for power of a quotient. So we have a fraction that's to an exponent. And here the exponent applies to the numerator and the denominator. Keep that in mind. So what will this become? Take away the parentheses. It's going to be y to the 5th over x to the 5th. There you go. This is going to be 3 to the 3rd, and then over 4 to the 3rd, but they do want you to simplify that. 3 to the 3rd is 27, and 4 to the 3rd is 64. I really like the way they are showing and presenting these PowerPoint slides. All right, on the numerator, we're going to get 2 to the 4th, which is 16, over a to the 4th. And there we have it. So this will be x to the 2nd over 7 to the 2nd. 7 to the 2nd is 49. So they want these simplified. Now, this one gets a little tricky now. So keep in mind what's going on. And I'll write this one out. So here we're having in as our base negative 2 to the 3rd, x to the 3rd, y to the 6th as we do this multiplication. Now, negative 2 to the 3rd, an odd exponent, negative, this is going to be a negative 8 then, x to the 3rd over y to the 6th. All right. Now I'm using what they are giving us just to kind of speed things up a little bit. I could write them all out, but it would take a long time. So here we have two ways to do this. Now we could do some canceling and subtracting inside here. Let's check that out here. We could say subtract 2 from this 3. So this will become a 1 here. Just a plain A. This disappears. There's a 1 here. This disappears here. And this just becomes a 1. So we get 3 squared over now a squared, b squared. And 3 squared is 9. So we can just put a 9 there. And that's our answer. That's one way to do it. I have a feeling they're going to show us both ways here. All right, no, they're showing us the way I mentioned. And they get it that way, yes. Now, the other method, okay, they're going to show it to us in 2 separate slides. The other method is to actually do the multiplication, clear the parentheses, get all of this, and then simplify from this stage. And the answers come out the same. So a couple of techniques here. And now combining rules for exponents. Now this is one that sometimes can slip by without noticing. And that is if you have a negative exponent of something, of a fraction, you can make that negative exponent positive by just flipping the fraction. Let's see this in action here. Okay, so how can I make that exponent positive here? I want to have this exponent that's negative become a positive 4. Well, we said just by flipping the fraction, in a sense, taking its reciprocal. So this is y to the 5th now over x to the 3rd. Ah, that's pretty easy. So this is going to be y to the 20th over x to the 12th. And we can go on here. So there it is in its original form. By making our exponent positive, we just flip the fraction, take its reciprocal, as we say in formal terms. Now another way is you could just have this be x to the negative 12, y to the negative 20th, and then just put those in the proper position. That would work too. And then now this goes up and that one goes down. There you go. So again, sometimes there's more than one way to do things. Now in our last example, here it gets rather complex. So we'll follow what the book has, and I'll explain what's going on step by step. But notice what you could do is you could flip this, and this becomes a positive exponent. You could flip this, and this would become just to the first power. So you wouldn't need parentheses here. And then you could work through it item by item. So there they're starting. Haven't done anything yet. And they are flipping this to get this, and flipping this, and again this becomes a positive one now, so they have that. So they're now getting rid of the parentheses up here by distributing that 2 in there, and then they are going to get 3 squared is 9. This is x squared already. This is a y to the negative 4. 2 squared is 4. X to the 4th, y to the 6th. So not too bad. And then this one we didn't change anything yet. But we can do some simplification. Now we go 9 times 3, because nothing cancels out. This is going to be a 27. We're going to do our exponents here, kind of combine things, so eventually you get to this stage. Now you're going to take your x to the negative 3 down. We're going to add it to this x to the 6th. This is going to become x to the 9th. And then this negative 1, we bring it down, becomes a positive 1, y to the 6th. And that's what we have. They brought them up first. I don't know why they did that. I would have brought it down right away. Okay. So here's a brief summary of rules that you should have in your notes. And pause if you want to check them again. And these are all of the others. And here are some practice problems, but we're already at over 20 minutes here. And then if you want to pause, you can. A few more, and then these are the answers. So, okay, we've divided this lesson into 2 parts. We've done a lot of work with exponents.